Hey everyone, welcome in. We will go ahead and get started in just a quick 30 seconds or so. And while we wait, as always, feel free to say hello in the chat and let us know where you're from. Oh, we gotta have more than just Memphis here. Thank you, Sam. Oh, they're rolling in. Got Mexico. That was a great game. If anyone's watching the World Cup last night. Okay. Well, they're rolling in. I think we have a lot to get through today. So while y'all are still saying hello, I will just go ahead and kick us off in the interest of time. So welcome everyone again, and thank you for joining us for another AEE webinar to discuss some advanced building technologies that are benefiting from investment tax credits in the US. My name is Ian Watsky, and I'm the Membership Development Manager at AEE. And I'm joined by a panel of speakers today I will very briefly introduce them, and then they will all get to tell you a little bit more about themselves in their portion of the presentation. I'll start with Jack Deanna, who is the chairman of the International Ground Source Heat Pump Association. Jack is a nationally recognized authority on renewable energy technology, specifically focusing on geothermal heat pumps, which he'll get to tell you a little bit more about today. Joining Jack is Mick Dunn, who is a technical manager of Templock Energy Savings Ceilings at Armstrong World Industries, where he specializes in integrating phase change materials into the built environment. With over 20 years of experience, he bridges thermal storage technologies to drive energy efficient building solutions. Joining Mick and also from Armstrong is Stephanie Dorman, who is the Incentives Program Manager for Armstrong World Industries. With almost 2 decades of experience in energy efficiency, she works to provide clear and actionable guidance to support organizations through investment tax credit 48E for energy saving ceilings projects. And last but not least is John Caporal, who has more than 20 years of experience and is the Senior Director of Renewable Energy Tax Incentives at Walker Blue, where he supports clients that are navigating federal clean energy incentives, including investment tax credits, compliance requirements, documentation, and credit monetization strategies. So before everyone gets into their portion of the presentation, just want to say a huge thank you to all four of our panelists today for being here and taking the time to present. And I would also like to give a special shout out to Julian Martinez from Walker Blue, who also has helped organize this webinar in the background. Before we get into it, I have some quick housekeeping items to review before today's webinar. First off, just starting with the fact that this webinar is being recorded, and we will be sending out a follow-up email tomorrow morning with a link to the recording, as well as a link to view and download the slide deck from. So be on the lookout for that email in the morning. This webinar also offers 0.2 AEE credits for live attendance, and you can view and download your certificate for proof of your credits directly from the AEE education website, which is the same page that you joined the webinar from, and it should pop up automatically as soon as the webinar is over. In case that does not pop up, or if you want to reference that certificate at a later date, you can download your certificate at any time by clicking the My Dashboard button on the education website. And then once you're on that page, you can select transcripts and achievements. And from there, you can view and download all of your webinar certificates. There will also be an on-demand option for 30 days after this webinar that will offer AE credits for anyone who can't attend live. So everyone here is attending live, so it won't apply for you all. But for any future webinars, you now have this as an option. You still need to register for a webinar ahead of time to actually have access to the on-demand version for credits. So even if you can't make it to a webinar in the future, still be sure to register if you would like to have access to the on-demand version for credits. Very quick thing for the actual webinar today. We should have some time at the end of the presentation for a quick Q&A with the panel. So if you do have any questions along the way, please just put those directly into the Q&A box, and then we'll try to leave the chat open for general discussion. And if you would like to direct a question to a specific panelist, please just make a note of that in the question as well. And that is it for my updates and housekeeping. So with that, I'm happy to officially welcome and turn it over to our first speaker, Jack Deanna.
Thanks, Ian. Good morning, everyone. And I want to thank AE for having me speak at this webinar. I've been working with AE for probably 30 years. Just a little bit more about myself. I'm not only the chairman of the geothermal of the International Ground Source Heat Pump Association, but I'm also executive director of the Geothermal National and International Initiative. Jack, if you could put up my first slide. Thank you. Okay, geothermal heat pumps. Well, this is a new 40-year-old technology. It's actually been around for a very long time. Unfortunately, because of the fact that we're either underground or inside, no one knows where it is. So what we're doing right now is bringing this to the forefront because this is a renewable technology according to the Consolidated Appropriations Act of 2021. It's also one that is a renewable that this administration, excuse me, fully backs. You may have read about this that the initiative for geothermal, both deep G, which is electric production, direct use, which is used deep G used directly at the spot, and geothermal heating and cooling, which is what we're going to talk about now. This is really the energy under our feet. It's something that we can do everywhere. I know we've got a lot of people on this webinar that's all over the world. It is done all over the world. The big thing about this is that as my slides say, it's 24/7, 365 baseload power. So it's basically the energy under our feet, a virtual power plant. It's actually a distributed energy resource for those folks that are in utilities. Once again, we've always talked about energy. We've always talked about energy in the form of miles per gallon. What actually everyone doesn't realize is 40% of all the primary energy used in the US is from buildings. And 40% of that energy is used in water heating and cooling. Next slide, please. What I want to talk about is we're focusing, at least the initiative that I'm involved with, we're focusing on schools. K-12 schools in the United States are the second largest public infrastructure investment in the US, and one of the biggest energy consumers. They spend over $8 billion annually, and a lot of people don't realize that. And they use 8% of all the energy used in commercial buildings. And once again, they emit as much carbon dioxide as 18 coal power generating plants. The funny part about this is that we're using schools. I'm 80 years old. We're using schools. We're putting our kids in schools in buildings that I could have gone to school in as a elementary school student. Next slide, please. The thing that we're talking about now, and you've heard us talk about the fact that the grid is very fragile. What I'm looking at is this technology, geothermal heat pump technology, according to the Maryland Energy Association study, for every installed ton of capacity, we reduce peak load by 1 kW. So if you look at what I'm saying here, there's 129 public and private K-12 schools in the United States with 3.6 million students, a lot of whom are in buildings that we wouldn't go to work in. 50 years old, 41% of those have failing HVAC systems. That equates to 52,500 schools that could be replaced with a geothermal heat pump system. Now, the big thing here is this has been around 40 years. The big change is, and if you look at the total potential savings, 15.4 gigawatts, that's like building a new power plant, actually building 5 new power plants. And all we're doing is providing heating, cooling, and water heating to schools. The difference is this has been around a long time. I've been working working with schools for a very long time. Um, what I'm looking at right now is what has changed. And what has changed is the big, beautiful bill when that was passed in July of 2025. It did a number of things. Next slide, please. The big, beautiful bill, we had an investment tax credit for commercial and institutional that was not touched in that bill. As a matter of fact, it added to it. Right now, a nonprofit prior to this was not eligible for an investment tax credit. Right now, we have direct use, which allows a nonprofit such as a school to achieve that 30% commercial investment tax credit as direct pay. We can also have domestic content because 90% of all the uh, uh, everything used, all the equipment used in our technology is made in the U.S. Another big thing is what's happened prior to this. When I would talk to school, the big concern would be how do we pay for this? Well, in that same bill, the big beautiful bill, there was an exemption to the IRS policy of limited use property doctrine, which created geothermal systems where they can be now leased by third party. So that means we take that high upfront cost away from the end user and put it in going from capital expenditure to operating expense. The IRA also included a 6% tax credit for commercial building owners, including institutional buildings. So next slide, please. What does this do for school districts? Well, as you can see, it increases comfort, better learning ability, healthier environment, reduced maintenance, and lower cost. Now, that healthier environment has been studied by both Harvard University and Yale University, and they discovered that higher relative humidity impedes the transmission of respiratory viruses, which is COVID. So if you're in a heating only school, which is where I live in the Northeast and all the way to middle America, 90% of all our schools are heating only, which has a relative humidity of about 10%. If we install geothermal heat pumps, which is heating and cooling, which gives a better learning ability because we have a structured environment, it also increases relative humidity to 56%, which once again, now we're talking about a healthier environment for both students and staff alike. Who's involved? Designer, driller, installer, heat pump manufacturers. I'm assuming if you're an AE, you're probably an engineer or an architect or a designer. What's changed is the organization I represent, the International Ground Source Heat Pump Association, has all the training involved that can get you back into how to design, how to install, what the necessary items are that you have to know to put in a very good project for the end user. One of my chores is to make sure that the technology, the integrity of this technology is kept. AE has been a partner with HVAC, the International Ground Source Heat Pump Association, for over 20 years. This pardon me. This technology is actually a triple E technology. And by that, I mean it's energy independence and security, it's environmental stability and resilience, and it's economic prosperity and sustainability. So we hit the grid, we hit the environment, we also hit creating jobs. And that's basically the end of my presentation. Once again, this technology is 40 years old. We can do it just about anywhere. The only place we can't do it is over nuclear waste sites or caverns. But if you want more information, you can go to the HPA website at hpa.org, igshpa.org. Thanks very much for your attention. I'm done. Thank you.
Thank you, Jack. Hi, everybody. My name is Mick Dunn. I'm from Armstrong Ceilings. And if you're not already familiar with ceilings, the image here on the right is starting my video. Sorry, you guys. Something was There we go. Sorry about that. Armstrong Ceilings is well known for acoustical ceilings we see in buildings, schools, all types of spaces. And what we're going to be talking about today briefly is an introduction to how these ceilings can be turned into what we might consider as thermal energy storage systems. If we want to jump to the next slide. Essentially, it's introducing a very unique, innovative technology called phase change material. And so, if you've never heard of that, essentially, anytime a material is undergoing a change of phase from a solid to a liquid or a liquid to a gas, it's undergoing a phase change. And so, it takes a lot of energy to change something from solid to liquid, liquid to gas. We use this all the time in our buildings with refrigerants going from liquid to gas. And that's what makes heat pump systems like what Jack was talking about so efficient is we're leveraging what's called the latent heat of some of these materials. In our case, we're talking about leveraging similar things on solid to liquid. So if you want to try to imagine that, you could think of it like ice in a cooler. When you take ice or frozen water out of your freezer and put it into a cooler, it's exposed to a temperature above 32 degrees. That's the melting point or 0 degrees Celsius of water, and it will begin to melt and absorb heat. That's what's keeping the cooler at that frozen or cold temperature until it's completely melted, and then it will rise in temperature. And the same thing actually happens on the reverse side when you go to freeze that water. If you leave a cooler outside in a freezing cold climate, it will actually release heat as it refreezes until it's completely frozen, then it will drop. So the question we're talking about today is like, what would happen if you could use a phase change material, in this case, a mineral-based formulation using salts and water that transitions or phase changes at room temperature. And in this application, we're talking about integrating it with a ceiling because temperatures rise in a building, and in the ceiling, we tend to be always running a little bit warmer. So we can absorb heat as spaces rise in temperature during the day and then release that heat as the ceiling recharges. So we're converting our ceiling into a thermal storage device. So the way that operates is very similar to traditional thermal mass. We could think of one ceiling panel, one 2 foot by 2 foot ceiling panel, having the similar amount of thermal energy storage or thermal mass as 10 to 11 bricks worth of mass. And really what's happening then is that we're helping reduce peak temperatures in spaces to help control the demand for especially air conditioning in the afternoon, but also for heating benefits in the wintertime if we want to jump to the next slide. So I'll just be covering a little bit on how this actually gets integrated into buildings before transitioning over to Stephanie, who's going to cover the tax credit opportunities with this. What's unique about ceilings is that we're installing ceilings in big buildings every day of the week. And so this is already something that's being deployed that's kind of unique when we think about renewable energies. People aren't tending to put solar panels and other sort of renewables into buildings because they're delivering, say, an aesthetic or an acoustical benefit. Whereas these assets are already being deployed into buildings. What we're talking about is converting that same system into something that can deliver a thermal storage benefit. And so this is a technology that's integrated with ceiling tiles in 2 foot by 2 foot and 2 foot by 4 foot sizes. And what you can see on the bottom right there is the backside of the panel has a pouch that is a foil film sealed pouch that is integrated and laminated to the back of the ceiling so that as the ceiling is installed, there's no added cost to the labor. Each full tile on the ceiling system integrates with this phase change material. So wherever there's these MEP, mechanical electrical devices, say a sprinkler head or a fire alarm device, kind of like what you see in the image here, maybe a lighting or supply return diffuser. These would be a regular ceiling tile where it needs to be cut or modified, or perhaps at the perimeters. All of the full tiles are where the phase change material gets deployed, and that's what converts that system into an energy storage asset. There's no active moving parts. It's just completely passive, responding to the natural temperature changes that happen in the space. And all of this can be integrated to match existing ceilings or in a brand new construction project to sort of meet all of the architectural and acoustical requirements. Jumping to the next slide. So now what this sort of does is give us this ability to help support both comfort as well as energy in terms of being able to reduce operating in spaces that are using air conditioning and heating, where we can reduce up to 15% on the energy side for HVAC systems and leverage some of the tax credit benefits that go with that. So piggybacking on what Jack was talking about in terms of schools, this is a really unique opportunity. We get a lot of schools in the built environment where there's huge numbers of schools that were built without air conditioning, sometimes even 10, 15 years ago, especially when it's 60, 70, 80 years ago. Many of these schools are in conditions now where they need air conditioning, either due to more population growth or climate changes in their local area. And sometimes you just needed to install some of this air conditioning for 3 to 4, 5 weeks of the year. We're not saying that a ceiling is necessarily going to solve that, but it is certainly going to help, as we'll see in the next slide. We've got some information or data from, say, a test of using these phase change material ceilings in Palm Springs, California. This is in a desert environment, really hot, and comparing rooms side by side with and without the technology. You can see on the left, the ceiling temperatures up above the ceiling are getting close to 100 degrees, and therefore the room down below, the ceiling temperature in the room is exceeding 80 degrees by mid-morning in this desert climate, even in late May. And so what happens when we add the phase change material and compare multiple rooms on average, we see a big reduction in that temperature, and the room itself doesn't exceed some of those temperatures until later, much later in the afternoon, in conditions where air conditioning is running non-stop throughout the day, can't keep up. These are talking about like portable classroom type environments that are very difficult to maintain. So this is a technology that can be helped to underpin thermal comfort and support air conditioning and heating usage reductions. And then obviously, as we're talking about, Stephanie will now cover, is the opportunity that this brings to the federal investment tax credit and how that can introduce reductions in budgets. So Stephanie, if you want to take it from here.
Yeah, absolutely. Thanks, Mick. Yeah, so in ITC 48E, which is about a year and a half old now, and it did make it through the big, beautiful bill last year, uh, thermal energy storage is specifically called out, and phase change material, which is used in our temp-block ceiling tiles, is a form of thermal energy storage. So our biggest question when all of this came through was what all qualifies for the tax credit. So we worked with a tax advisor to do a review of the actual code as well as our system. And it's been determined that the 10 block ceiling panels and the accompanying grid and any perimeter trim transitions and the labor qualify for that tax credit. We are at a 40 or 50% tax credit. It is domestic content. We've had that certification done. We meet all of the FEOC certifications. And because the ceiling tiles will be under 1 megawatt of thermal energy storage per year, we hit that 40%. Now, if you're in an energy community, it's at 50%. Next slide, please. So the IRS actually has a website up that will show you what areas are existing energy communities. So anything in pink or green would qualify for a 50% tax credit, again, on those 10 block tiles, the accompanying grid, trim, and the labor. And anything that's not in pink and green would be at 40%. Next slide. All right, so who can use 48E? Just like Jack was saying earlier, the option of elective pay or direct pay allows school districts, universities, nonprofits to qualify for the tax credit. They cannot transfer that credit. They actually receive a direct reimbursement after the project is complete. They'll file all of the same paperwork. They'll put it onto their 990T, and typically within 30 to 60 days of IRS review, they can expect to receive a direct deposit of that tax credit. Anyone who is tax paying, so companies, organizations that do pay their taxes, they would claim that tax on the tax credit on their yearly filing. So if they're installing it this year in 2026, they could effectively take advantage of it when the project is complete by reducing their federal tax payments in a quarter, and then they will file for the credit with their 2026 taxes, and they can transfer that to other buyers. Next slide, please. All right, so this is an actual example of a project that has specified temp block. It's a school district in Texas. It's about 100,000 square feet with roughly 60% coverage of temp block. One of the biggest questions we get, and I saw it pop up in our Q&A session here, is our schools are funded by bonds. This project's funded by a bond. Do they still get the tax credit? The answer is yes. So this actually is a school that is paying for part of the project with bonds. They do have to put up some of their own capital. So this shows what the tax credit will be after a 15% reduction in payout from the IRS. So schools can still file. The IRS can keep up to 15% depending on how much of the project was paid for with the bond. You can still see that it's $180,000 savings by using temp block. Next slide, please. And I think we are over to John. Oh, you're muted, John.
Yes, of course I am. Well, thank you, Stephanie. Great time to be transitioning here because we'll pick up with the next part of the conversation that you introduced us to. First, I'd like to welcome everyone and thank you for being here this morning and this milestone week, of course. We have a big celebration coming up this week, and of course, I'm talking about the 1-year anniversary coming up of the One Big Beautiful Bill Act. I remember what I was doing a year ago right now, and it had to do with congressional reports and such, and it was sort of surreal. But in any event, we are Walker Blue, and we work with energy firms, consulting firms, engineering firms, facilities managers, as engineers and as tax professionals to assist and support and help to optimize your tax situations and get the biggest benefit for you. So a little bit about my background. I go back in the renewals. My first project was in 2002. It was a wind project in eastern New Mexico. This is not Sunzia. It was adjacent to Sunzia, though, in eastern New Mexico. And it was the first wind farm, major wind farm in the state. And from there, I worked for a bit at the Department of Energy in New Mexico, Los Alamos National Lab, did some work as commercial technology commercialization, renewables, and such. And so that's my background that has brought me to renewables and to storage and this time of a very interesting time that we're in. So what we'd like to talk about today, now taking from where Stephanie opened up and Jack introduced us to the idea of geothermal systems and application in schools, and then Mick, of course, and their products that are very interesting and do provide a lot of additional opportunity for efficiencies and use of that energy stack that a school has. We're going to talk a little bit about IRA and what this unprecedented opportunity is for schools to modernize heating and cooling systems for less than half the actual cost. And I've done a lot of these types of projects in the Chicago area, and I'll tell you, upgrading a 100-year-old boiler system to a modern geothermal system, it's life-changing. As Jack mentioned earlier, there really are significant health effects, benefits, and so our job is to help you optimize and figure out how to do that. So we'll start by next slide, please. We'll start by talking about the Energy Act of 1975. No, just kidding. Fun facts, though, that's where we got our petroleum reserve requirements from, our first automobile mileage requirements, and our appliance standards came from that act, our first national policy around energy, and here we are today. So let's talk about the base cases in renewables, and that will give you a sense to build up. We'll all get on the same page with how we're going to show and demonstrate the financial and economic benefits to you and your schools. The base rate is 6%, and that is because there are a couple of requirements that are that are built into IRA, and that would be either it's below 1 megawatt of output. If we're talking batteries, it's storage. They actually have input generated storage is a requirement, but we're talking about geothermal systems. If it's less than 1 megawatt, there's a 30% credit available as an automatic step up. Also, if it's a larger system, if you are compliant with the prevailing wage and apprenticeship laws, that also gives you that 30% step up. There is a timeline in phase out, and this is part of the original IRA. It did not change under the OBBB, fortunately, and that would be through 12/31/32. And of course, with your budgets and your committee work and things that you need to do to get systems spec'd out and approved and financed, that's not that far from now. There is a phase out that goes through 12/31/34 for the stragglers, but we focus on the 12/31/32 date as the critical. Bonus adders, Stephanie got into these a bit. We have, again, the same dial down to 2% for the adder bonuses, and that's because, again, it's tied to the 1 megawatt of output, the smaller projects, or use of prevailing wage and apprenticeship labor in the larger projects. And these will be for energy communities, domestic content, which has its own requirements, which have changed, modified over the last few years, low-income communities, and then there's a kicker bonus for low-income residential building projects within low-income communities. Next slide, please. Stephanie mentioned grants and tax-exempt bonds. They're a part of your world, and this is wonderful. They have been taken into account in the IRA, and here's how it works on a high level. The effect of grants would be that for direct pay, now this is, when I say direct pay, I mean the elective refunds, the ability to get a refund for the tax credit, even if you're not paying tax. That's essentially a refundable credit. This is a first, this, at least in this area, and this is what has opened the doors, opened the floodgates to having this something that all school districts that have these situations or these conditions should be looking at this opportunity for as a generational opportunity, essentially. And so the direct pay projects can receive grants, and the grants can offset part of the installation, can be included in the basis. This is important. You can include the grants in the cost basis, and here's how the reduction works, if there is a reduction, and in many cases there's not a reduction. If the total amount of your grant and your ITC, your tax credit, exceed the cost basis, so you've got a $2 million project, you've got 1.8 in grants and credits, you're not going to have to cut back your tax credit. If you have a $2 million project, but you've got 2.2 million, then you're going to have to cut back your credit by that delta, by that 200K. And so that is very generous, and it's good for you to know and understand. Grants are going to be allowed. Tax-exempt financing, a little bit different. This is going to require a cutback. We generally go with this 15% as a rule of thumb, and the reason for that is there is some math involved, but because of the way the math works, it's generally going to be a 15% reduction of your credit, essentially taking a 30% credit down to a 25.5% credit, or the bonus down from a 10% bonus credit down to an 8.5% bonus credit. So it's still fairly generous. Pre-IRA, it was a 50% cutback. So this is pretty good. Next slide, please. All right. A couple of things you probably have heard: FEOC and domestic content rules for tax exempts. That second part is a specific rule that applies to tax exempts. And so this is important to understand. It's not the same thing as the 10% bonus for domestic content. It's a reduction or a cutback in your credit if you do not meet the domestic content requirements. And so that's important to know. You've got to look at domestic content two ways in your determinations. So the first cutback would be if you're not meeting the domestic content requirements. Just as an example, in 2025, last year, because we're still doing the last year's work right now, we're processing last year's work. You had a 45% domestic content requirement for the business. If you do not meet that for your project, you will then have an 85% credit. That table there, that short table, will give you that math. The problem really kicks in this year. I want you to see that 55% domestic content level. If in 2026 your project does not meet or is not able to meet domestic content, you could have a zero credit. That's very important for you to know up front in your planning, in your strategy, in your capital stack evaluation. Very important to know. There are a couple of exceptions. Don't really want to get into them because you really don't want to have to take that approach because it's subject to review. But there are a couple of possible exceptions. Next slide, please. I'm sorry, FIAC. I jumped. Again, it's probably just a reaction to FIAC when I see it. So this is the Foreign Entity of Concern rules. This is from OBBB. This applies to all projects in 2026, and this is going to focus on two things. And again, this is extremely high level, but keep in mind supply chain sourcing for parts and components, and ownership tracing and business relationship analysis. That's the tricky part. That's where we have to look at ownership. We have to look at things like license agreements, all kinds of things like that to see who's really owning or involved in the transaction. And it can't be an entity from one of those four target nations. Then material assistance, some new regs came out. I'm sorry, a notice just came out a few weeks ago that we've been poring over. We're hoping for more by the end of the year. I was at a conference a couple weeks ago. Treasury guy told us they're coming, but he wouldn't promise. So this is, again, very important to keep in mind. The sourcing of your components and your engineers, facility people need to know this more than anything, and that needs to be evaluated as part of your capital stack calculations and determinations. Next slide, please. Okay. Elective pay ITC is a refundable credit. It's fairly straightforward. Again, you know this is more complex than on the slide here, but this is just to give you an overview. First of all, you got to qualify as either a Section 48 or 48 Cap E investment tax credit. And under 48, the geothermal heat pumps are grandfathered, so you're going to get those qualifications. A tax exempt organization, of course, your schools. And that would be public and private schools are typically going to qualify here. The owner of the facility, you've got to be the owner of the facility. There are arrangements with third-party ownership. That's fairly complex. We're not going to talk about that today, but it's not over if you can't do this on your own. I'll leave it at that. And then the validation of the ITC and the bonus credits. That's the engineering, making sure that things comply, they qualify, all of that stuff. Then there's a process, a pre-registration process for the ITC. This is with IRS through a portal. If you're going for a low-income community bonus, you've got to do that well in advance because those are competitive and it's limited to how much those allocations are going to be. And then at the end, you file a Form 990-T, and you say, John, we never filed a tax return. How do we do that? You simply file one time, and that would be to get that refund. Next slide, please. All right, this slide is going to pull it all together, and hopefully I'm going to give you some math to chew on, and so here we go. So Jack talked about GHP systems earlier, 2.2 million GHP system. Folks, Mick talked about the radiant heating tiles, and so we're looking at 200K for that, just as a number, okay? Total qualified ITC costs, 2.4 million. Here's how this is going to work. We're going to be looking at, and we're going to skip tax exempt financing first. We're going to get a state energy efficiencies for schools grant, 20%. That's pretty sweet. But the money is available. California is going through that right now. We raised $1 billion through tack-ons on energy bills. There's about 200 million sitting there that the PG&E is just dying to get its hands back on, and they're promising us $1 a week cut in our energy bills if they can get their hands on that 200 million. Sounds like a pretty good deal, right? For PG&E, of course. Then there's the base ITC, 25.5%. It'll be $612K. The energy bonus, let's say it's in an energy community, $204K there. Domestic content bonus, $204K there. And I'm using the reduced credit because now we're getting back to the tax-exempt bond financing. So the delta is going to be the $900K. So the tax-exempt bond financing in this case is going to be just under $1 million, and that is our capital cost. You're looking at our capital stack, and we're looking at an unsubsidized cost ratio of 37.5%. Facilities managers, superintendents, finance managers in the school districts, that's a huzzah to you. You've done a great job. And that's my walkthrough, and hopefully there's something meaningful. We'll get the slides, and we're available for questions anytime afterwards too. Thank you. Ian, I believe we left some time here for questions, and hopefully we'll get into some really interesting topics.
Yeah, absolutely. Thank you very much, John. We are looking very good on time, actually, so we should have plenty of time for questions and some, follow-up conversations. I would invite the other panelists, just if you want to turn your cameras on, we can more or less start the Q&A portion of the webinar. So for everyone who's attending, if you have any questions, now is the time to throw those directly into the Q&A box. And then if you would like to direct your question to a specific panelist, please just make a note of that in the question as well. We did have some questions come through, and I saw there was, I think all of them actually received typed answers, but we can start going through those out loud. I think that would be beneficial too. This first one that came through, Jack, I saw if I can get Jack to maybe get his camera back on too. I saw that we had Jack typed an answer out to one of the questions that asked, when schools are bond funded, I've seen traditional HVAC systems selected due to lower capital costs. How can life cycle cost savings and other benefits of geothermal be better emphasized in school construction projects? Jack, if you don't mind just expanding on what you typed in already.
I'm sorry you cut out there could you repeat that, and I'd be glad to do that.
Yeah. I was just referring to the question that you had typed an answer to that was when schools are bond funded, that question.
Oh, sure. Yeah. Even though they're bond fund, well, right now with the HVAC, and I'm going to talk about the HVAC in a school project, which is really what I'm involved with. Right now, with third party, the Big Beautiful Bill did one other important thing, and that is they put in third party ownership to be allowed for geothermal systems. So what I'm speaking to schools right now is that if we're looking to put in a ground source or geothermal heat pump, we can actually take that whole cost away from the school, take it from a capital expenditure to operating expense. That leaves them more room if they're trying to do other improvements with that bond to use that bond for other improvements. So the actual cost of the geothermal system, the ground source system, is actually owned by a third party ownership. I should tell you that I did this. I ran a geothermal subsidiary for a utility that gave me $15 million in 1985. And what I did is I owned everything. I owned the ground loop and I owned Insight for 20 years. That's effectively what the Big Beautiful Bill has done. So it doesn't affect any bond. It doesn't affect what it does do. It takes the cost of the geothermal system from capital expenditure for a school to operating expense.
Okay, thank you very much. Yeah, and I know we had referred to this question earlier, and I think Stephanie, in your portion of the presentation, was there anything that you'd like to add on to that?
Yeah, so what we're noticing, my school district's installing temp block right now. And their whole reasoning for installing temp block was the federal tax credit. What they're getting back is over $500,000 estimated, and they already have projects lined up for that. So, what schools and school boards are really focused on right now is looking at that tax credit and what future projects that they can plan, because funding at schools is so limited.
Okay, thank you. And that brings me to one of the other questions that came in the Q&A box. And I know we've talked a lot about schools. There was a question that asked just simply, does the tax credit apply to corporations? So I'm wondering if you all can just touch on how this kind of expands to outside organizations other than just schools.
It, just for me, it applies to all commercial installations, not just schools. Schools happen to be one of the things that we're really focused on because of the need. And but yeah, hospitals, prisons, office buildings. I'm sure Stephanie and Mick and John will agree with that.
Yes, Jack. This is John. I've actually I've done several projects in corporate campuses. The one of the upsides, of course, because their capital flow and strategies, they're more they're less cash sensitive. These projects move forward more quickly. But the advantages to the taxpayer, of course, not only do they get the ITCs, they qualify, they can get depreciation benefits. And that's a big kicker in addition to the ITCs. They can get a bonus depreciation, which means that and that came from OBBB. Bonus depreciation was going to be 40% this year. What that means, what bonus depreciation is you're allowed to take an excess amount of accelerated depreciation to take your deductions faster. Bonus came back at 100% with OBBB, and that's something that corporate interests are very appreciative of. And so not only do they get the tax credit, they get the accelerated depreciation, and can write this off in year one. And they love the energy efficiencies. I mean, they do a lot of determinations based on their energy use, and these are real guidelines and cost benefit analysis type things they do, and so they're incentivized to do these types of projects.
Nick, Stephanie, anything from your end on how corporations are utilizing these?
On our end with TempBlock, we're seeing corporations. We had one that actually filed last year. We have a case study on it. But when the project was complete, they effectively took the tax credit on their quarterly tax payments, therefore easing up some cash flow in that quarter. And then they filed for the tax this year, and it went on their 2025 yearly filing.
Okay. Great. Thank you all for that. And we can move into the next question, which I saw Mick took a stab at in the Q&A box. And they asked, how can the ceiling phase change material be evaluated in 8760 energy modeling software?
Sure. So this technology's been we've been doing a lot of work on modeling related to it. It's something that's in a very well-known energy modeling software called Energy Plus that the Department of Energy helps manage. Some work is being done to improve that right now and fix a few glitches in that software. But currently the technology's in another platform or software called IES Virtual Environment. On an 8760 model, which is a little bit more sort of spreadsheet based, perhaps is how you want to think of it. We recommend at this point just kind of treating it like a traditional thermal mass, and that's something we can kind of help support without going into all the details of how that gets done. But there's some ways that could be considered in a traditional sort of simpler modeling software approach like that.
Okay, awesome. Thank you. And that brings me to a good point that I don't know if we got to that slide in the slide deck, but all of the panelists' contact info is in the slide deck for anyone who does want to follow up and have those kind of more in-depth conversations. And everyone will be receiving the slides after the webinar. So you will have everyone's contact info. One other question that came through that I think Jack had typed out an answer to is the question is GHP technology applicable for cooling buildings in island environments? So I guess warmer and more humid environments. And also, how does it compare to ocean thermal energy conversion?
Well, first of all, it's a 40-year-old technology, so we're well developed. And the answer to the first part of that question is absolutely. Uh, that we've done projects in a lot of the Caribbean islands. I've actually done a project in Saudi Arabia. So the cooling aspect of this is the ground temperature in the islands, even though you may be reaching 90 to 100 degrees, the ground temperature is about 75 degrees. There's a big delta T there. I also did this in India where the ground temperature was 75 degrees. So the cooling aspect is definitely doable. It also reduces the amount of electricity in most of these islands. They're importing all of their energy, all their power in diesel or anything like that. So the more we can do to supplement or to reduce that need or the amount of energy used is also beneficial. Someone also asked the question, can this be used in hospitals? Absolutely. Hospitals have a bigger need than most because they've got 57 different uh, environments that you have to deal with. So yeah, we can do hospitals, prisons. There isn't anything unless we're in a nuclear power or a nuclear generation site or anything or caverns. Typically, it goes on design, and since we're in AEE, your audience is the key to this. They've got to know how to do this. And the exciting part about this is, and I want to thank you for having me on here, because I learned about the other product at Templock, which I didn't know about, which seems to be really a cool application for a geothermal system.
Mhm. And Mick and Stephanie, how about for the PCM ceilings? Are there any regions or kind of environments that you see this, I guess, most utilized at this point or best utilized?
I think from the technology perspective, it's really more about building conditions that experience temperature changes. So it tends to be more widely adopted in applications where there's buildings that are occupied during the day and more empty at night. So you could maybe change your control set point, have a setback so that the building will cool down and tends to heat up more naturally. It is favorable in more sort of hot climates, desert climates where there's larger temperature changes. So there's certainly building types and climates that are a little more favorable than others. But it tends to be a good fit whenever we're in more commercial buildings where there's predictable occupancy so that you can maybe leverage some cheap cooling early in the morning or some ventilation to freeze your ceiling system and help support during the day. But then on the tax credit side, whether somebody's saving, say, 4 to 7% versus 13 to 15% doesn't really impact the tax credit side of things. I think for you, Stephanie, you've probably been seeing that pretty nationwide, right?
Right. It's a federal tax credit, so everyone in the country or territories does qualify for the project. And I saw a question on here for Walker Blue about new construction and retrofits for schools. The tax credit applies to both for schools. For any project, it can be retrofit or new construction. What we're seeing in most K-12 schools is retrofits. That can be full grid replacement plus the tiles. Sometimes they keep the grid because it's a standard grid. We don't have to change the grid. There's nothing special needed there. So the tax credit will apply to whatever materials are needed to support the qualified technology, which are the Templok tiles.
That's great. And John, did you want to add anything to that question that Stephanie referenced about do the tax credits apply to both new construction and retrofit replacements or renovations?
Yes, what Stephanie said is the rule. The way it works is you've got the ability to not just do new construction, but you can go in and retrofit. There are requirements on how much of the retained facilities you can reuse. It's an 80-20 rule, we call it. But yes, retrofits are perfectly acceptable and encouraged.
Okay. Jack, I saw you typing an answer, and I think this is definitely the
Yeah,
last question we have time for.
sure,
Did you just want to take a stab at that one while we have a second? They
sure.
asked, do you have to
The
be
question that
over?
Nancy asked was, does it have to be over an aquifer or near lakes,
Yep.
etc.? No, it does not. It needs to have ground that we can drill into. There is a system that uses an aquifer that's very limited. There's also lake loops that you can use if you have an active lake that's very deep. Uh, that you can use instead of having to drill loops, which is our loops are made of high density polyethylene, which is as a that loop has a guaranteed life 50 to 100 years. The inside has a guaranteed life from ASHRAE 20 to 25 years. But no, it does not have to be near a lake or an aquifer. It can be done anywhere. The only limitation is you can't drill over a canyon. You can't drill.
Okay. Awesome. Well, thank you all very much. We got through quite a lot of questions and a lot of content in a very short amount of time, so really appreciate all of that. Um, I can start to wrap us up here. I think that's all the time we have for questions. Before I do, I always like to give the panel an opportunity if you have any concluding remarks or anything you want to leave everyone with before we wrap up. And if we can keep it at maybe 30 seconds or so per person, we should get out of here just on time. And I'll just go start maybe on the order you're coming on my screen. So Jack, we can start with you if you have any concluding remarks.
Sure, I would say that I noticed we had some people from New Jersey. New Jersey, the clean energy program just is now subsidizing HVAC training up to $4,000 for the training in New Jersey, so you can get trained and also get paid back. So, thank you.
Stephanie, you're next.
Yeah. Again, you'll get the slides, but go ahead and reach out. We have a lot of resources, including how-to filing guides for 3468, and how Template qualifies, along with all of our certifications on FIOC and domestic content that your clients will need for filing.
Okay. Mick?
Yeah, I think concluding would just be hopefully you learn that a ceiling can do something more than maybe what you're used to in the past, and maybe start thinking about it as one that can actually, if you utilize these tax credits, could cost less than regular ceilings you're putting in on at least this front. And you've got the team here that can help support.
Awesome. John, you want to bring us home?
Yes, please. Thank you. I love sitting in these types of panels because I'm learning new things, new products, new approaches. But the important thing is stay the course. These are generational opportunities, whether you're public, private, corporate, schools, municipalities. This is generational. I've been adjacent to incentives and credits now over 20 years of my career. And when I see something like this, when I saw something like this, I felt the significance and consequence. And it's all about the monetization, folks. This is generational. If you've got an idea or a plan or want to do something, run with it and talk to folks like this on this panel, and you'll do well. Thank you,
Absolutely.
everyone.
All right. Well, thank you all. I can start to close this out. And I do just want to say a huge thank you to all of our panelists for taking the time, presenting, rolling through so many of those questions. I think this was a very interesting webinar for me to be a part of too. And some thank yous coming through the chat. So I think it was a good one for all the attendees as well. And I also want to give a special thank you one more time to Julian Martinez from Walker Blue, who helped kind of pull the strings for this behind the scenes. A couple quick housekeeping items before I let everyone go. First is that we will be sending out a follow-up email with a link to a recording of today's webinar and a link to view and download the slide deck from. We'll be sending that out tomorrow morning, so be on the lookout for that. Another reminder that you can access your certificate of attendance for this webinar directly from the AEE Education website as soon as we're off. It should automatically pop up on the screen from the same page that you joined from after the webinar. In case it doesn't, you can also access this and other webinar certificates at any time by clicking the My Dashboard button on the education website. From there, you can select transcripts and achievements, and you can view and download all of your certificates. The next AEE webinar is going to be on July 23rd. We're calling it an AI Bootcamp to discuss how to utilize AI for smarter audits, faster analysis, and better results. So as always, you can find more info and register for that webinar directly from the AEE website. And lastly, just want to thank everyone again for attending today's webinar. Thank you very much to our panel again. We can go ahead and conclude the session, and I hope you all have a great rest of your week. Thank you all.
Thank you.
Bye.